So hi everybody. I think most people know me. How many have lived the entire 5 years of DSdB? And how many is this the first time you've been at a CHERI event? So that's interesting, isn't it? So, for me, obviously, I was one of the primary authors on the original bid while I was in ARM. What do we do with CHERI? Because obviously in ARM we were looking at it. What can it do? Can we get it over this hurdle of, good research, but it's a pretty big change. Does it break anything? Does it work? Does it actually secure things? And really, for the last 5 years, and as most of you know of the DSbD, the actual programme ended on the 31st of March, a couple of days ago. What have we found? And really, that's what I'd like to cover, a little bit about what might happen next. But obviously, in terms of what we said, so who was at the showcase? So quite a few. So obviously at the showcase, I gave the three headlines that we sort of extracted. And the way we extracted it is all the projects. So there was about 80 million pounds spent on various projects, some bigger than others, where they all looked at what it meant to them and their software and their platforms and their security primitives, etc. Now, I think as a whole, what we found is actually, yes, what it says it does for security, it does. Tick. What it needs in terms of code change and lines of things like that, and the experience of a developer doing it, manageable. I think that's a case. And then when you start looking at the businesses that might use it or benefit from it, you can sort of start saying, well, actually, there's the opportunity to actually lower and reduce your costs. So that really, as a headline, the three headlines, what we extracted from all of the research was it reduces your business costs, okay? And the reason we had an S on the end is it's business costs in development, patching. We've had, obviously we used for a long time and still do use the Microsoft, Google 70% number. That has obviously got pushbacks. Oh, that's IT. IT's not secure. It has all these big problems. But then we've also had people looking at automotive stacks, Zephyr stacks, other more embedded applications. And I would say, actually, the truth for the memory safety stuff, it's in the 50 to 60% in the operational technology. The only ones where actually it goes much lower than that, and it doesn't go to zero, is where they're spending significant time on formal verifications. So actually running the verifiers on every line of code. But even then, we have seen memory vulnerabilities coming through. And what we found then is the experience for those developers that are having to do those verifications has actually also improved if they've got a CHERI platform under them. So, whether or not it's a bug that you're doing your verification, you're doing your address sanitizers, your val grinds, you're doing every formal thing you can on the code, and then you find that the assumptions between two of the modules wasn't quite right, and bang, you get an error on the abstraction between them, or it just missed it. CHERI is actually fairly vigorous for the developer, but it's also very precise. So you get an error. It says, error. How many developers here have traced a bug down in multiple days, weeks, or even months? God, yeah. I remember one of the big bugs I did when I was coding. It took me 3 months to find. I haven't got time to do that, but basically it was the next nearest thing to a bug in the computer. It was a pair of pliers that got warm, expanded, shorted across a couple of address pins in the server and would crash that morning because it was just getting up to temperature. Ugh. And it was remote. It wasn't until we visited and took the machine out. Anyway, so the experience of users also improves because obviously, today, you are responsible for the cybersecurity of your devices. Now, imagine you're a business delivering a service to millions of people. You are responsible for it. And obviously, the recently announced, which one was it, the Cyber Resilience Act thing is expanding who becomes responsible and how you are seen to be responsible. So, the government's really starting to view the importance of that. It's not just the end user that has to be responsible. It's coming down into the supply chain. The supply chain now needs mechanisms by which they can de-risk the potential liabilities, threats, log a business, all those good things. So we're now seeing that experience for users improving. So what do you start seeing when you actually, now you've got your reduced business costs, you've got the fact that the user developing systems have more tools and more mechanisms to create more resilient and integral systems, potentially safe, hopefully as well, but definitely more secure and resilient. And the end user now isn't having to distrust the fact their phone is a open repository to all of their data and their life and their money, which it is today. You start seeing that actually the overall resilience of the world improving, which is really the top level headline that I think we have to take away, is that this inflection that obviously the researchers have been on it for 2010, was it, Simon, something like that? So we're well into, I think we'll have a look at those capability stuff again. And we're now actually at the stage of it works. It does do what we hoped, which is reduce the effect and vulnerability. We found that the experience of developers is better. We found actually there are opportunities for fairly significant performance uplifts. So some software developers say, I've got to keep these two things separate, and the only thing they can do is inter-process communication and processes. Capabilities that basically allow you to do compartmentalization, and you can get order, if not 2 orders of magnitude higher performance. Okay, so you're really getting good. So the security and resilience. So what's next? And obviously I've got Brad talking next, so I've got to be careful what I say. But basically, we're at the stage in how do you get it adopted and diffuse the technology more broadly? And obviously DSIT did do a paper, research sales consultative paper that some of you probably contributed to on what are the challenges of doing that. So again, where we're at, we can't actually say this is happening. But I think if we look at what the DSbD program created, we've got thousands, if not tens of thousands of software packages that you can collect across all of the Gits and repositories of what you've got. How do we make that available for the people who actually want to deploy chips now? Because I think my latest count is, I think there's 5 microarchitectural implementations or companies, if you like, adopting CHERI. So we're at that fledgling point that the chips are on the way. Obviously, I think we've got CODISIP here as well. I can't see the other 2 or 3, but there's others coming as well. How do they know where to get the software? What software is at a maturity level that they can actually adopt and use? We've got, one of the beautiful things of public funding is you can quite often accidentally get duplicates. I think we've got 3 Rust compilers. Okay, which one is the one I should use? How do I get started with it? Okay, where do I get the version of LLVM for my C code? All of those questions. So what we're trying to do is we're looking at what interventions we can do within across the ecosystem in terms of consolidating, giving a central location for pushing that forwards, holding where the outcomes of projects go. Now, clearly, we did a lot of projects previously. I wouldn't be surprised if there's more project funding on the way in the idea of, okay, guys, you've got your Java to that stage. How do we get it to that stage you can use it? We've got the Zephyr thing at that stage. How do we get it to the point that you can actually use it? We've got the Linux coming through the Alliance collaboration at the moment. How do we consolidate that and actually make it a distribution with all the packages available? So you can imagine that kind of environment being supported by projects working on that. And there'll be tools, software, frameworks, probably not applications, because I think we're at the stage now that if you can give the environment for development to people who deliver applications, they'll go, fine, why wouldn't I? It's a better experience, I'll save money, customers will like it, yeah? But we have to get it to the point of deployment. But it's also, how do we make sure that those chips that are getting built have somewhere to go, have some support to accelerate their availability, the breadth of impact? Because clearly, CHERI, all the places we've tested it are good, but let's get them in as many places as we can, as quickly as we can. So I think that's not committing to anything, but that would be sort of the kind of thing you could probably see in terms of how do we get adoption and diffusion. Maybe Brad will amplify some of the broader initiatives in terms of, obviously, those are the encouragements. You might see some sticks as well coming along as well. So, I think the last one I'll mention, and of course we do have some of the more formally people here, who can define what memory safety is in different levels of definition. So how can you ask as a procurement, is it memory safe? So we need some language Okay, so, you know, let's get some language which helps us not define what it isn't, because we all know what isn't memory safe. It crashes because you've got a buffer overflow. But what it is, if it's a good system that actually meets some level or some bar of correctness in terms of it's stopping issues at some level. And obviously different markets will have different levels of different requirements. Oh, look at that. I looked at that. And at that point, I had 1 minute. So I am here all day, so any questions and things, find me later.
Thank you. Bye.